Hello everyone and welcome to IBMathlogy, your space for mastering IBTP mathematics. So today we are going to study about Maclaurin series. Now why we use this Maclaurin series? Because when you have functions like, let's say, e to the power x or sin x or cos x, or even you have functions like ln, log functions. So Maclaurin series convert these into some powerful polynomials that you can use for solving questions in your exam. Now how it will convert? Let me show you. So by using this formula, it converts every type of polynomial, whether it is algebraic or these above mentioned polynomials. But the important thing to note here is every function, whatever is going to an infinite polynomial, it is always centered at x is equals to 0. That we have to keep in mind. If you can see that everywhere you can see 0. It means we have to take derivatives depending upon the question, how many derivatives the question wants, and then we have to put the value x is equals to 0 into the function or question. Now sometimes they ask for expansion, this is the expansion, but sometimes they want the answer in the sigma notation. So you have to write your answer in this sigma notation. Now let's take an example to better understand this. Now for example, I have a function fx is equals to 1 upon 2 plus x. Let's take this example, and now the question will say find m4x. It means we have to find the fourth order Maclaurin polynomial. Now how will you find it? According to this formula, first we have to find out derivatives. Now when you will find out derivatives, so f dash x will be minus 1. We can bring this in the numerator, so this will become power minus 2. Again I have to take second derivative, so let me take the second derivative. Second derivative will be 2 plus x to the power minus 3, and we can keep going on. So because it's the first example that we are doing, so I am showing you how to write the kth one also. So it will be minus 1 to the power k multiplied by the k factorial into 2 plus x to the power minus k plus 1, because you can see that every time power gets increases. Now this is all about finding out fx, but now we have to put x is equals to 0. So my f dash 0, when you will put into the function, you just replace x by 2, so you will get 1 by 2. Multiply by 1 by 2, so we will get 1 by 4. Now when we'll substitute 0 in the second derivative, so we will get 2 multiply by, you can write it like this for better understanding. So this will be 2 by 8, that is 1 by 4, and we can keep going on. Now if I want to expand this and write, because I have to write m4x, means I have to write first 4. So I'll go according to the formula given. So I will write fx as f0 will be 1 by 2 plus x times my f dash 0 is minus 1 by 4 plus x square by 2 f double dash, that is 1 by 4. So we got first, second. Similarly x3 by 3, we will get minus 1 by 2 to the power 4 when you will solve it, and the last one for m4, it will be x to the power 4 1 upon 2 to the power 5. So you have to remember that this is M1, M2, M3, M4. So we always have to write F0 and then we have to count. Now we can further simplify this. So on simplification we will get 1 by 2 minus x by 4 plus x square by 8 minus x cube by 16, and the last one will be x to the power 4 by 32. So this will be my answer for the given question. Now let's take another example. So let's take another example of, let's say, fx is equals to e to the power x. Now we'll start with fx is given to us. So we'll start with f dash x. This will be e to the power x only. Double derivative will also be e to the power x, and so on. It keeps on going forever. Now replace x with 0. So we will get 1. Again, derivative is always, all derivatives of this function is 1. Now we will plug in into the master formula. So I will get f0, that is 1, plus x into f dash 0, that is also 1, plus x square by 2 factorial into f double dash 0, that is still 1, x cube by 3 factorial into again f triple dash 0, and so on. So on simplification I will get 1 plus x square over 2, x cube over 3 factorial, which is 6, and so on. So if you look into your formula booklet, this formula is already given to you. So now you can understand that from where we are deriving this formula. Now what if the question wants Maclaurin series expansion for the function e to the power 2x. So we already have e to the power x function in the formula booklet also. So what we will be doing, we have to replace every x with 2x into the e to the power x formula that is given to us. Now we will be using this formula. So my e to the power 2x will be 1 plus x will be 2x now, plus 2x whole square over 2 plus 2x whole cube over 3 factorial, I will write factorial here, and so on, 2x to the power 4 over 4 factorial, and so on. Now you just need to open the brackets. So after opening the brackets I will get 4x square over 2, 8x cube over 6, 16x to the power 4 over 24, and so on. So this is how we can expand any function. We just have to replace x with whatever is given to us in the function. Now if I want to write in sigma notation for the same one, so what I will be writing is summation. My n always starts from 0 and it will go towards infinity. So if you can see here, it was 2x, then 2x squared, then 2x cubed, then 2x to the power 4. So here I can write 2x to the power n, and in the denominator it's upon 1 factorial, then 2, then 3. So I can write it as n factorial. So if I want to further simplify, n will be from 0 to infinity. This is 2 to the power n multiply by x to the power n over n factorial. You can leave your answer here also, or you can simplify it further also. Now let's understand how to write Maclaurin series for composite functions. Composite functions means when we have a function inside another function. So question will be like, use Maclaurin series expansion of 1 upon 2 plus x, that is given to me like this, 2 to the power k plus 1 multiply by x to the power k. Now we have to use this to find the Maclaurin series for, let's say, 1 upon 2 minus x square. Now first, so this is the question. Now how we will start? So first of all, 1 upon 2 plus x expansion is given to us like this. So we will compare this with the one which we need to find. So if you can see that here your x is being replaced by minus x. So what we will be doing is we will write first the summation, that is k is equals to 0 to infinity. Again minus 1 to the power k upon 2 into 2 to the power k plus 1. It's a constant. It will not get affected. Now we will look at this x. We will replace this x with minus x square and then we can write it like this. Now our work is done. We just need to simplify it further. So if I will simplify, it will be minus 1 to the power k, and this I can write as minus 1 to the power k multiply by x to the power k upon 2 to the power k plus 1, which will further give me my answer as minus 1 to the power 2k into x to the power 2k upon 2 to the power k plus 1. So you know that minus 1 to the power 2 will result in a positive value. So I can remove this. So my final answer will be x to the power 2k over 2 to the power k plus 1. So Maclaurin expansion of 1 upon 2 minus x square is this. Now we'll substitute and expand our answer. Now let's say we have to write first 4 terms. So I will replace x with 0. I will get 1 upon 2. Then I will replace x with 1. So I will get x to the power 2 over 4. Then I will replace x with 3. I will get this, and the last one I will get this as my answer, and it keeps on going. So this is how we can write the terms of the series up to x to the power 6. Now let's try another example. We are given with the Maclaurin series of cos x, that is k is equals to 0 to infinity 2k factorial multiply by x to the power 2k. Now we have to find Maclaurin series for cos x square. So here also instead of x I will replace x square. So I can write the above expansion as, this is a constant, so this we will write as it is. My x will be replaced by x square, so this will become 2k. Again the summation thing will be the same. The constant I will copy as it is, so this will be x to the power 4k. Now what we have to do is, again we have to start by replacing k. So my first one will be 1 plus, now I will replace k as 1. So this will become minus 1 over 2 multiply by x to the power 4. Now I will replace k with 2. So it will be 4 factorial multiply by x to the power 8, and it keeps going on. Now let's solve some of the questions that involve addition, subtraction, division, integration of the function using Maclaurin series. Now in this question we are given with cos x Maclaurin expansion and sin x Maclaurin expansion. Now we have to write the terms of the Maclaurin expansion for sin x plus sin 2x. So for sin x we can copy down this expansion, but for sin 2x what we will be doing is we will be replacing x with 2x in the expansion given. So I will use this one and I will substitute, replace x by 2x everywhere. So it is 2x to the power 5 over 5 factorial minus 2x to the power 7 over 7 factorial. Once I have sin x and sin 2x, now I can add these two. So my sin x plus sin 2x will become x minus x cube over 3 plus x to the power 5 over 5 factorial minus x to the power 7 over 7 factorial. Now I have to write this plus the addition sign. Now I am expanding it. So I will get 8x cube over 3 factorial plus 32x to the power 5 upon 5 factorial minus 128 over 7 factorial into x to the power 7 and so on. Now I can add this x with this x. So I will be combining the like terms. So I will get 3x. After that x cube term when I will be adding, I will be getting 9x cube over 3 factorial plus 33x to the power 5 over 5 factorial and then 129x to the power 7 over 7 factorial and so on. So this is the expansion for sin x plus sin 2x. Similarly, let's look at the other question. Now in this question we have to use the Maclaurin series for sin x to find the Maclaurin series of sin x whole square. So again we will be replacing this x by x square. So for sin x square I can write this as it is because it's a constant 2k plus 1 factorial. Now instead of x I will write x square and then this. Now this I can write as x to the power 4k plus 2 and this everything will remains the same. K is equals to 0 to infinity. So this is my expansion for sin x square. Now there is no need to further expand. But what if in the question it says integrate this from 0 to 1 like this? So what I will be doing is, since I have found out the expansion of sin x square, so I will be putting everything inside integral, that is integral k is equals to 0 to infinity. These all are constant. These we will be taking outside the integral because these are constants. So when I will be taking this as outside the integral, it will become this 2k plus 1 factorial. Now my only work is to integrate this. So the integration of this will become, I will apply power rule. So this will become like this. Now I just need to substitute the limits. This thing will be the same, so I am writing it as it is, 2k plus 1 factorial, k is equals to 0 to infinite. Now when I will be putting the limits, I will be getting minus 1 to the power k over, so in the denominator I can write it like this factorial multiplied by 4k plus 3. Now I have to put upper limit, so 1 minus 0, that becomes 1 and the summation keeps as it is. Now when I substitute k is equals to 0, my first term will be 1 over 3. When I substitute k as 1, I will get 1 upon 42 plus 1 upon, when k is 3, it is 0, 1, 2. Then if I substitute 3, I will get like this, like this. Now if you use your GDC and you directly see the integration of sin x square dx, you will approximately see the answer as this. And when you will add all this, its answer is almost the same. It means that by using technology and by using Maclaurin, we are getting the same answer. So that's all for today's video. In my next video, I will be solving some past year paper questions related to Maclaurin series. So don't forget to like and subscribe my channel for more updates. All the best everyone.